Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. So today we present for the first chapter. So for the subject BEEI 1453, electronics in people for chapter 1, the introduction for semiconductor diode. First, as a lesson outcome for this chapter is we can explain the basic structure of atom, differentiate the characteristic and properties of insulator, conductor, and semiconductor. These three types of structure, difference in terms of its atom, understand the covalent bonding, identify P and N type semiconductor, explain the operations of diode characteristic, understand VI diode characteristic, and classify diode approximation. As introductions, we go for Bohr model. So Bohr model seems like our planet, where we have a proton and neutron in the core of it, where electrons are orbiting around the nucleus, right? So nucleus is consisting. So nucleus, just like our Earth, are being orbiting by the moons. Okay. So first, we have to know what is electron, what is proton and neutrons. First, electrons. Electron is refers to the minus charge. Electron is minus charge, proton is positive charge, neutron is uncharged, where it orbits shells. From the Ne is a 2n square, and n is the number of shell. The outer shell is called valence shell. The less complete the valence shell, the more conductive the material will be. So valence electron from the nucleus go beyond the layer of valence. The more layer we have, the more energy increase. Okay? Energy level are increasing with more layers of valence. First, when we compare these two electrons, the first one is less energy compared to the above one. So this valence electron, and each layer for this type of have maximum of each valence electron. So valence one will determine the ability for material to conduct current. The less complete with valence electron, the more conductive the material will be. So the process of losing a valence electron is called ionization, where when the atom absorbs energy, it gains extra energy to lose bounds, becoming free electron. Okay, then atom that lose its valence electron become positive ion. Okay? And the negative ions are originating from the free electron, and electron captured that release energy, so it becoming negative ion. So this is the three material classifications that divide into conductor, semiconductor, and insulator, where we can compare. The most important is on the valence electron, where conductor, it has 1 to 3 valence electrons compared to semiconductor 4, and insulator 5 to 8. For conductor, it has more tendency to lose valence electron because it less valence electrons. Therefore, as per introduction before, the lesser valence electron, it easily can conduct electric. Came to the second classifications, because second category is semiconductor, where it have four valence electrons. And in these situations, it is easy to allow atom to lose or gain free electron. And the first conductor we have gold, silver. So this is the main material that can be used for our electrical system, especially for conductor. Next is germanium or silicon. So this is the material for semiconductor because it acts as conductor and insulator in between. Okay, and the last one is insulator. Normally it carries about 5 to 8 electron valence. Therefore, it has a tendency to gain, compared to conductor, lose. Insulator gain free electrons to become free electrons. Okay, does not conduct current. Normally, insulator happen to use as a to protect our circuit from short circuits, such as neon and argon. Normally, it's an insulation medium, neon, argon. Alright. Copper insulator semiconductor. When we compare between copper and silicon, a copper only has 1 electron in its valence ring. This is the outer ring, we have only 1. So this 1 electron are indicating, as I've said before, is a good conductor. So if we calculate by the formula of 2n square, in this case 32 electrons are need to fill up the valence shell. Therefore, okay, when we compare with silicon, the outer valence shell have 4 electrons. So this will act as a semiconductor. So in this case, it needs 18 electrons to fill the valence shell. Okay, compared to the first one where only 1 electron. So it needs more between copper, between this is conductor and semiconductor. We need more additional electron to fill in compared to semiconductor. So to know more about this situation, you have to know about energy band, energy level, and energy gap. So energy band are divided into kinetic and potential energy, where kinetic is energy of motion, potential is energy of positions. So in this case, energy increase as the distance from nucleus increase. So the nearer we to the nucleus, it have less energy compared to the outer shell. Okay, so this is the comparison. We have insulator, semiconductor, and conductor, where each material possess different bands of conduction and valence band, and this is a level of energy. So for insulator, the energy gap is high between the conduction band and the valence band, and semiconductor is a bit lower, whereas for conductor, the conduction and valence bands are overlapping. This is the situation, especially when you can see that the difference is between the energy gap, right? So therefore, in this first chapter, you need to know the basic structure of atom. What is proton, what is electron and neutrons, what is valence shell and valence neutron, and classify 3 different materials. We have conductor, insulator, and semiconductor, and define energy band, energy level, and energy gap. So next, covalent bonding. So covalent bonding is a bonding of 2 or more atoms. This is being done if we take the subject chemia. or chemical, and secondary, your SPM. So by the interactions of these valence electrons to strengthen and stabilize the atom bonding structure. Normally, the center atom shares electron with each 4 surrounding atom. When you say we have this is silicon, are sharing with 4 different silicon atoms that creating 1, 2, 3, 4, which is a total of 8 that is covalent bond with each other. And then this surrounding atom are turned into bonded atom and so on. So this link will create a bonding that's signifying that the red negative sign signifying the shared valued neutron. So it will strengthen and also stabilize the atom bonding structure. So a certain atom will combine and it will form a crystal structure. So silicon and germanium combines in a way in their intrinsic, so we could, or in the pure states. It will bond in this way and becoming a crystal structure. So semiconductor are classified into 2 main categories. We have intrinsic and extrinsic. So intrinsics, it refers to the very pure, chemically pure semiconductor material, and it possesses poor conductivity. Okay, because it has equal number of negative carriers and also positive carriers. Okay, a silicon crystal from metal at any pressure so 0, there is a finite that will knock from its leaving the electron deficiency called hole. Okay, that's the problem with the intrinsic semiconductor. So this is the material that is a pure chemical. So intrinsic is a pure chemical, poor conductivity, possess equal number. This is the intrinsic semiconductor, and it tends to lose its position affected by temperature. It's easily lose its positions when affected by temperature, and existing of holes produce current when voltage are applied. So this is the if I shown before, when it subjected to heat energy, it will produce free electron, because the free electron will tend to search for holes, and this hole tend to attract free electrons. Okay, it will keep balance. When holes positive charge turn, so intrinsic silicon gains sufficient heat, some balance could break a covalent bond. So these covalent bonds are break because of heats. With existing of holes, current can be produced when voltage applied across the terminal. Okay. Therefore, because of the electron hole pairs are matching each other, therefore it produces a less conductivity or poor conductivity compared to the extrinsic. Whereas intrinsic is an improved. Why it improved? Because we introduce an impurities by the process of doping. It's not doping that the Olympic doping, but it's doping that used to alter the electrical properties. It's same way like steel alloy, where we introduce additional impurities to improve the mechanical properties. Therefore, for electrical, use different impurities, okay, combined to improve its conductivity. So the process is doping process that control the conductivity, and this doping process will produce 2 types of semiconductor. We have N-type and also P-type. N-type refers to negative charge conductor, and P-type refers to the positive charge conductor. So intrinsics is an improved intrinsic semiconductor, where we introducing impurities through doping process. So this doping process can control the material conductivity to produce 2 different types of semiconductor group. We have P-type and N-type. N-type and P-type semiconductors. So the process, as I mentioned before, is called doping. So it improved the electric characteristic of silicon and germanium. So for N-type, it's called pentavalent impurity, where this is antimony, Sb is referred to antimony, is added to the silicon to increase the free electron, because the outer layer has 5 electrons at the outer shell, and this outer shell are combining with 4 different outer valence electron that have 9. Therefore, we have 1 free electron from this antimony atom. Compared to the p-type, so this will produce negative. So because electron is negative, right? Negative charge ion. Compared to the p-type, other atoms, because this is boron, so boron will have 3 electron outer. So therefore, with 3 added by 4 outer valence bond from 4 different silicon, we have 7. Therefore, we less 1 holes. So this deficiency will produce hole. So holes, it refers to the trivalent impurity. So this trivalent will produce holes, will produce positive charge. Alright, so doping process will add a number of electrons in the holes. There are 3 categories. If we use a trivalent element, there are boron. Normally trivalent element because it's tri. Okay, tri is compared to 3. Yeah, because we have 3 outer shell or 3 valence electron. Okay, such as boron, gallium, aluminum. Whereas penta, 5 valence electron. Penta is referred to 5. Tri is 3. As Sb, arsenic, phosphorus, and bismuth. Okay, so the doping process. So for trivalent elements, it has a less valence electron. The atom tends to accept free electron because it produces hole, right? So trivalent element is called acceptor atom. Therefore, it becomes a p-type intrinsic semiconductor. Whereas pentavalence, because it has more valence electrons, it tends to donate the electron, known as donor atom, and becoming N-type insulated semiconductor. So this is the difference. The p-type will have hole, therefore it is a acceptor. This is a donor, it gives a free electron. So p-type semiconductor, the trivalent atom combine with silicon to form a covalent bonding. Okay, alright. So hence this material consists of holes as the majority carrier, p-type, and electron as the minority carrier. Since the whole majority, so the material classified as p-type semiconductor, therefore it's called p-type semiconductor. Okay, because it's in holes gets 3 valence, where the holes, so holes will attract free electron. So for N-type, the pentavalent atom combine silicon atom to form a covalent bonding. It consists of 5 electrons, but only 4 needed because you get another 4 from silicon. But it leaves the free electron becoming free electrons. Hence, the material consists of electrons as the majority carrier. Alright. Therefore, holes are the majority carrier. There's the majority carrier. The material classified is N-type semiconductor. So because we have free electrons, okay, extra becoming a free electron. Therefore, we call a negative electron majority as a majority carrier. As a summary, so diode and transistors are made of semiconductor. So Bohr model, just to give an understanding of the circle, how the electron circling. So the atomic structure, okay, it determines the ability either to conduct or insulate. So the energy band, okay, on the electron surrounding the electron shell, and each shell define electron in the hole. The outer shell is called valence shell. The valence shells is ability to conduct proton and energy kept with different energy level of conduction and valence band. Right. So covalent bonding to and or more atom interactions. So as a first short assignments, I need you to answer this five questions and submit me next week before the class. All right.